to Developer Wednesdays here at the Bitcoin Center, the Blockchain Center here in the internet. Today we are literally going to be adding your coin to Uniswap. Like that, like a quick little censor I did.
We have to censor ourselves.
No, we're free agents. No, today we're adding your shitcoin to Uniswap.
Nice. That's what I like to hear.
I know. I was taken aback for a second. I was like, I'm gonna curse on camera, but today it's not just a clickbait title. We are literally going to go from the very beginning and really try to go from end to end on how what Uniswap is, for those who don't know, and for those who have found us because you do know what Uniswap is and you want to get on Uniswap. We're not just going to do a hold your hand type tutorial. We're going to go into the smart contracts and to the actual mechanics of how it works. Isn't that right, John?
And the front end.
And the front end.
How you can fork the front end, add, modify it as you please, create your own pool.
Yeah, it's basically
and pretend you created it.
Yeah, so we can fork. Well, so just the outline of the stream, we're going to be forking both the core and the front end repositories from GitHub. The links are going to be down below. Changing the environment variables to point to the Covan test network. So anything that we are doing here today is not real, quote unquote. We're deploying to the test network and not actually minting coins on stream.
Yep.
Well, we will be deploying your shitcoin on stream, but it will, because what's interesting that we found is that as soon as you add liquidity and something against Ethereum, your coin starts having value, which could be, really problematic for us, especially if we're minting it live on camera.
I didn't mean to click that. Did you see that?
No, what was that?
That comment.
But that's what that's the brilliance of Uniswap. It gives your token value.
Yeah,
that
because
doesn't mean your token will still have value, but
it has some sort of value once we're inside here.
Temporarily, until people take all of it.
There's another question. How do we get the bots out of stream?
Yeah.
We got some bots.
Yo, dude, listen.
How are the bots entering the stream?
They're inside the comments. They're like, yo, totally buy a weekly income. I'm like, no, don't do that.
It's the best.
How does this work? Like,
how there bot accounts on Facebook and YouTube.
Facebook.
Are we on Twitch yet or no?
Why aren't we just doing this through Twitch? I feel like that's the move.
Well, it's not an and or type thing. Well, it's an and, not an or thing, because we can go to all of them at the same time, and there's really nothing that can stop us for that. But what I'm saying is, we gotta get rid of those bots, or at least try to figure them out. We just gotta get some mods go in there. But just a quick overview.
Let me get it. I'll get on the mod. Let me get over there.
All right, cool. Yeah, kick in whatever that Angela bot is. Angela Bradley. Goodbye.
Adios.
Okay. So,
yeah, dynamic trading bot.
So
she's not a bot.
Where do we want to start here?
Well, let's go.
We go on about bots all night, but
well, I know the outline of the stream is just from. There's 5 things what I have down here. We're going to be forking both core and front end repositories, learning how to change the environment variables so you can talk to the Covan network, and that's why we got into that. But then we're also going to be deploying our own shitcoin testnet, creating a pool on Uniswap via the front end, and then we're going to dive deep into under the hood and over the hood, as it were, right?
Okay. Yeah, I feel that's a good summary. But first, what is Uniswap?
What is Uniswap? Do we want to go when we go to the site? Adam, you can talk about
us?
Yeah, it's how do we put it? It's like a liquidity pool with an automated market maker built into it. So meaning you start 2 separate sides of the pool, and then whatever point the price is determined by the point at which it's currently trading at. So it moves up and down a curve, and the automated market maker is essentially the pool just filling in and removing orders. And as it goes up and down the curve, you have a slippage function, meaning like it drops a percentage point or whatever, depending on how much liquidity there is on it. So it's essentially just like it's like how do I put this? It's like you want to trade, your tether for like Ethereum or whatever the hell, but somebody has to provide the liquidity, so they put equal amounts on both sides, and then they have like some functions that basically calculate what the current price is depending on how much tether and how much ether are in the pool, and then it fills the trades and pays out the people for on the back end for providing the liquidity to be able to do this. So it's an automated market maker with a deterministic pricing index based on how much volume there is.
Yeah. Do you see my screen? I have.
Yeah, that was very good.
I was like,
that was as good or better as I could explain it. And I had no idea how much you even knew about Uniswap. So
I know a lot about it. So
I just figured you would, because being the kind of person you are. But,
yeah. So
because you're such a swell guy.
Thank you so much. So on the back end, there's actually a couple different components about Uniswap that make it significantly interesting. So they say they use, bonding curves, but actually it's like a different type. So like bonding curves as they were made were like integral, like they add up, right? Like you bond and build a price point. The way that Uniswap did it did a two-sided pool. So it's more of an automated market maker rather than a bonding curve. The automated market maker is actually the curve. That's like what you would define it as. It's not so much like you're bonding to it when you're trading with it. You're actually just, swapping. That's so like Uniswap's a really good name actually, because you're going from one thing to another. It's pretty freaking cool technology. It's revolutionized, a lot about exchanges. And I think in the future, you're going to see a lot more centralized exchanges getting smoked by something like Uniswap, because the fees are incredibly low.
Look at this. We got a graphic.
Extreme flexibility. You have, you can actually be anonymous. Like you have anonymity on the internet, right?
Mm-hmm.
But with something like Uniswap, where you don't have to know the other trader, money goes into a massive pool and nobody really knows where it's coming out. And I mean, you can try to estimate, but it actually does create the anonymity for trading that we've talked about the past for cryptocurrency. This actually allows it. And it's really exciting. So I'm gonna let you guys go. I'm sorry.
No, it's good. No, it's right. I'm trying to be like trying to display it here on like the side over here while you're talking. So you can see right here we have a liquidity provider, and then we have a deposit of token A plus token B, and the output is basically shares. So you get a Uniswap token to, which is something that we're going to be speaking about later, is that you post that coin, which you'll see our own personal shit coin and our own personal set of Ethereum. And that is how we will be able to stake, and we get back a share or a Uniswap.
Oh my God, bots.
Yeah, their bots are everywhere. So it says, Uniswap is an automated liquidity protocol powered by the constant product formula and implemented as a system of non-upgradable smart contracts on the Ethereum blockchain. It obviates the need for trusted intermediaries, prioritizing decentralization, censorship resistance, and security. Uniswap is open source software licensed under the GPL.
That's important.
Each Uniswap contract or pair manages a liquidity pool made up of resources of 2 ERC2 tokens. Ooh, we got another one here. So we have the amount of the token, and that it's basically increased liquidity reduces price slippage for trades. So the I guess that's X times Y is equal K. So if you have reserves of one token, you get the more liquidity, increased low slippage area. So that's what you're talking about, that bonding curve. So instead of like having it's on the other side of the parabola, as it were, right?
It's like so
the amount of the token and the amount of the token. There's 2 tokens.
Yeah.
So it's Ethereum and our shitcoin, and then you get a Uniswap back. So pairs act as market makers, standing ready to accept one token for the other. This formula is most simply expressed by X times Y is equal to K. states that the trades must not change the product K's pairs of the reserve balances X and Y because K remains unchanged from the reference frame of a trade. It is often referred to as an invariant. This formula has a desirable property that larger trades relative to reserves execute at exponentially worse rates than smaller ones.
There's also something to be considered as well, which comes into like DeFi and everything else. There's this concept called impermanent loss that occurs when staking tokens in something like Uniswap, which
I was reading about that inside of its documents. Yeah, because some people may be like, wow, the amount of money that I put inside is now less instead of more than I took out. And that's what you mean by like an impermanent loss, right?
Yeah. It's a little bit more complicated than that, but essentially you can say there's not enough liquidity and you stake it into an AMM, it's going to fill every trade regardless. So there's no real way to have an automated market maker. It's going to fill the trades. To have automated market makers, you typically need a trade. So sometimes by adding an abstraction layer and creating smart there's ways to fix it, but like no good ways exist yet. I mean, we actually kind of have a solution Eric and I talked about that could solve it, but it's a long story.
Yeah, the scope of that is broad, and I think that we really kind of Uniswap has its place inside the market, and what they do is it's amazing. So that's why we want to talk about it. Let's see, smart contracts on core. Yeah, that's what we're going to be getting into today. Uniswap v2 is a binary smart contract system. The core provides the fundamental safety guarantees for all parties. Periphery contracts interact with one or more core contracts, and they themselves are not part of the core, which is, for instance, what we're going to get into, the router, right? I think the router's in here, yes. What specifically we're going to get into, correct, John? The router contract?
Yes. So there's a core set of contracts.
Yeah, so here's core. You have factory, pairs. Yeah. The core consists of a singleton factory and many pairs. You can continue. I'm just trying to be visual as you're talking.
So there's a core set of contracts, but the way you actually use Uniswap is you have an aggregator contract, also known as what they call a router.
Here it is. Router.
Basically holds together the glue of the core contracts.
So the router uses libraries, fully supports all basic requirements of a front-end offering trading and liquidity management functionality. Notably, it natively supports multi-pair trades, e.g. X to Y to Z, treats Ethereum as a first-class citizen, and offers meta transactions for removing liquidity.
Yeah, what a meta transaction is.
That's sick. Let's check it out.
So I could actually talk a little bit more about Uniswap. There's some things that I understand and like which comes into this. So one of the things that they do as soon as you have ETH in here is you wrap ETH, and one of the reasons you do that is because Ethereum doesn't actually comply to its own ERC20 token standard. Can you pull up wrapped ETH real quick and explain how this works?
Wrapped ETH?
Yeah,
is that like
WETH.
Okay.
So to solve some of these problems with Ethereum not complying to its own standard ERC20, because it can't. It's a long story. They explain it better on this website, but
what the WTF is WETH? Playing is WETH is wrapped Ethereum lets you start by introducing the players. First, there's the Ether token. Ether or ETH is the native currency built on Ethereum, and then there's altcoins, and finally the ERC2 standard. This is the one that's the standard developed on how to.
That's how Uniswap is possible, by the way, because you can't just do an ETH straight up.
Oh, here's what you're saying. Why you need WETH? Because ETH doesn't conform to its own standard, mainly because it was created beforehand.
Yeah, true that.
So it couldn't because this is an improvement, an EIP 20, the Ethereum Improvement Protocol. It's basically an open source thing. So it's kind of like, yes, of course it doesn't.
Yeah.
Because this is after the fact. Does not was a proto token of the Ethereum altcoins, which means it was built before ERC20 existed. Wrapping ETH allows you to trade directly with alt tokens. The reason why you need WETH is to be able to trade ETH for other ERC tokens. Blah, blah. Okay, so like Uniswap uses it. Because decentralized platforms running on Ethereum use smart contracts to facilitate these trades directly between users.
Worth noting, by the way. Makes Uniswap possible.
This ensures tokens don't get lost in translation. Ready to wrap. Well, this is awkward. So you don't actually wrap anything. When you wrap Ethereum, you aren't really wrapping so much as trading via a smart contract for an equal token called WETH. If you want to get plain ETH back, you just need to unwrap it, aka trade it back for plain ETH. Oh my god. This is a cool graphic, but that's just crazy. Whatever. Just give me the WETH.
That's how you do it. You can send it to the contract, you'll just get it back. And that's like how you get their ETH. It's not really complicated. It's just worth understanding that. Like, it's just nerd, but it's Uniswap wouldn't be possible without it. It's a reality.
Yeah. Okay. So So now we have a wrapped Ethereum. Okay. So this is the router contracts that we're going to be looking at. So just like a quick overview of what we're going to be doing today. It's not necessarily a live coding session, but a deep dive on Uniswap. So we got the superficial. Let's see. We can go superficial, but that's not our style. Our style is literally jumping down into the GitHub repositories and learning all about them. I think we can talk about them using this because it looks good. Can you see my screen as I'm talking, John?
You need to zoom in once, maybe twice.
Okay, ready? Bam, bam. Good?
Yeah, now it's all readable.
Cool. So let's go from all right, so this is the core contracts right now. And I'll be your, I'll scroll for you while you talk about it. This is Uniswap V2 Factory.
Okay, so we're starting with the contracts? Okay.
Yeah, we can start with the contracts. Then we can literally fork the front end and then start working with it, right?
Yeah. I kind of want to start with the front end, but
Do you want to start with the front end? We can. There's no rules here.
Okay.
All right, cool. Yeah, I can switch you over, and then we can switch back to my screen in case you need to explain something, right?
Yeah.
Here, I'll switch over to you,
Winston.
Are you? It's Winston. Yeah.
Who's Winston?
Winston is one of the interns for Zap. He's a really great front end designer, and now he's becoming a close friend.
Cool. Hi, Winston.
Yeah, he's not just another face. He's definitely cool. Anyway, I'm gonna switch. Are you ready to switch to your screen?
Yeah.
Okay, ready? Bam. Now you gotta zoom in.
So we are looking
Can you do a Control Plus?
Yeah.
Let's see. Give it 4 Control Pluses.
Okay.
Yeah, there you go. It's more like
Yeah,
So
and
we
now
are
get rid
looking
of
at
the sidebar.
Uniswap interface. Maybe
Cool.
I can switch to the GitHub, but ideally you would Git clone this interface.
Yeah, we won't get into that. I can switch over to mine too. I can go to the
It's pretty
website.
simple. But point is though, this is their open source interface, and if you want to learn React and you want to see an example of pretty well written React, this is a good one to start with.
Yeah, I was actually just thinking about that when we first were talking about Web3 React stuff. We actually were forking off of the code from their tech lead for Uniswap's tech lead.
Okay.
Yeah, what's his name again?
I think his name is Noah.
Let me look it up.
Uh,
I'm on it.
yeah, he's cool, but like I thought that was interesting. Oh, we
Yeah.
got more people in chat. Jorge, what's up?
So
And Phoenix, what's up?
to run it, all you need to do is they have a .env file they give out, and you just switch it to the network you want to use, which is simply Coven, which is chain ID 42. Now, if you do that, or if you want to use mainnet, you can use one. If you do that, and then you simply,
Are you clicking and changing stuff on your screen right now?
yeah, is it not?
No, I think you have the wrong VS Code showing or shared.
Okay. Yeah.
Because
Okay.
I was wondering why that was like.
Okay. Yeah. These are the actual Uniswap smart contracts.
Oh, okay, yeah, that's the smart, not the front end that you're using.
Yeah. Let me. How
That's
do
fine.
I
Take your
switch?
time. Here, what I'll do is
Let me
I'll
see.
go back to my stream.
Wait. Share screen. Wait. So I have to stop. And
Yeah,
then
I already share. I am already back to my screen, so you can go ahead and change your screen around, and then I'll call back to you.
Okay.
Let me see if we can actually
I
get
think
to
I'm
the
just gonna
GitHub.
share. I guess Chromium. Let me create a new.
You just look at the
Chromium window
title, and then you can do that. Let's see the
to
GitHub.
actually show you what the forked interface looks
Ah,
like.
here it is. So this is the GitHub that he's pulling up right now, and this is Uniswap's front end. It's written in TypeScript inside React. So we have the Uniswap core, and we have the
Fun
periphery
fact:
contracts.
TypeScript is one of the fastest growing web frameworks to use.
For sure, mainly because it brings like together like a sense of cohesion. At least that's what it feels like to me. Because now I don't have to like worry, or as a someone who's writing functions, you have to know the models in which you're trading back and forth. So it's good.
Yeah, there's a few tricks with React, but it's a
Once
very
it's in there.
popular stack for most decentralized applications.
Most applications, or at least like developed like full stack
As far
applications
as
where
web applications,
that
many
actually
of them are
need to be.
in React with TypeScript.
So on my screen right here, while we're waiting for John, you can see here this is the Uniswap version 2 core, periphery, and the interface.
You should click on the interface.
Say again.
Click on the interface. I'm just going to go straight
Interface.
to what it looks like when you actually deploy it. But
Yeah, okay. Yeah, we'll do a cooking show style. We don't have to. Yeah, just bring it up and then I'll switch over. But you can see here that it's actually really good. They have a lot of their so this is the environment variable that we're going to be changing here. So this is the obviously their master branch. So what we're going to be doing is we're going to change the app chain ID to 42. What is 42 other than like
that
the
is the
answer?
Coven testnet. It's
Okay, so it's not just
my
the
favorite
answer to
testnet
everything.
because there's like 4-second block times. So if you want to get things done fast on testnet, Coven.
But that also means that it's reset more often, correct?
I don't know about that, but I know it's not comparable to Ethereum because Ethereum is 30 seconds. So if you want to really simulate, the real I'm using Ethereum mainnet experience, Coven isn't for that.
I'm using.
Yeah,
Oh,
I have
boy.
to wait for things.
Yeah.
Coven's nice though if you just want to get your business, get your
it
testing done.
That's a good
Cool.
one.
So
I
what we're
recommend
gonna
Coven.
what we're gonna
I
do
was-
here as well.
I
is
was
change-
foolish and used Ropsten for a long time, and Ropsten takes forever.
Yeah. With experience, time. So right here at this environment variable, what we're going to do is that we're going to change the app chain ID to 42. And then we're going to change that instead of mainnet, we're going to go to Kovan. How do you? I would probably even save it around Kovan. Kovan.
Yeah, if you want to figure out what Kovan actually means.
Let's look inside the yarn lock file. Let's see what's inside here. That's probably juicy. So we got Babel. That's for Webpack. Blah blah. Cool. What else do we got in here? Uh-oh, that man gonna make my computer crash. Why is it doing this? Okay.
Maybe the package.json. There's actually a lot of dependencies because you have a lot of typings.
Oh my goodness. Okay. Well, this is not what I want. Package JSON. All right, cool. See, we got Ether's project. Okay, so that was like the waffle testing that we were speaking about before.
Oh, nice.
Popper JS. Don't know what that is. Interesting. Uniswap actually has its SDK, the V2 core that we were just speaking about. So we have all their contracts there to use. Web3 React, injected connector, some wallet connectors.
That sounds like a good band name. Injected connector.
Uh-oh. It's like his next. It's like his Web3 cover band. Playing the hits.
Pretty intense new metal band.
Yeah. Yeah, it's like playing the hits. Such as Uniswap. Copy to clipboard, cool. Got some more Jazzicon, cool. React Redux. Looks like they're using Redux for this. Rebase with 2 S's. Interesting. I wonder what that is. And styled components.
It's another band name. Rebase, 2 S's.
Rebase.
No, Rebass.
Rebass. It's like eating like fish again. Okay. So yeah, okay. So it looks like you could just hit yarn and then that will start React scripts start, React scripts build. Yeah, so it makes the Webpack at least a little bit more sane.
Nice.
All right, this is the deep dive.
That's a good one.
Yeah, and this is the core contracts that we were talking about. Let's do just a quick. Now, here's what I thought was really sick. It comes with all the tests here as well, so we can actually see into the test. So this is what I want to do for Zap as well, is like getting like an actual mock provider.
I wanna take some of their like concepts. Actually, they did some things well, and they're like I want to take some of their like automated market making concepts and apply them to like you can stake like your any token you want and end up with Zap on the other side, like to get in, like, you know, use it as an exchange interface. Be pretty sick. Like I don't know. Anyways, go ahead.
No, yeah, I'm just looking. So this is like the importance of testing inside of your work, because every aspect, transfer from, permit, these are all like the basic functionalities.
You guys still looking at the smart contracts, or is this?
This is the chai test of the smart contracts. So kinda.
Okay. Well,
what? Are you ready?
I have the front end. Yes.
Nice.
Uh-oh. Blah, blah. Let's go back.
Do you want to add a screen?
Yes. Hold on. Okay, I'm ready to. Now you zoom in.
So that's our local Uniswap. Wow.
Yeah, his is local Uniswap.
Yeah, this is my Uniswap.
Now from the comfort of your own home, Uniswap.
Uniswap. You can see that we have 1.7 Kovan Ethereum inside this. We'd like to reiterate that this is on a test network and that we're about to mint a shitcoin and add liquidity to a non-existent pool.
Yes.
You're gonna use open.
I actually have already minted a shitcoin, so we're
nice.
Yeah, we did. Cooking show style. There's one already here. Like
so I've already created a pool. So
it's like Julia Childs. John is like the Julia Childs of like crypto.
Shit tokens. Oh, shit.
No.
Julia
What
Childs,
is
oh,
he
shit,
like?
dude.
What
Who is
is-
Julia Childs? She used to
I-
do a lot of like French cooking on public television, and like
Okay.
you know, she's
Yeah,
like
she was a
really cool.
spy. She was a U.S. spy
Really?
during World War II. You didn't know
Oh
that?
no, I think I did hear about that, but
Yeah.
I didn't really believe it.
She's got a great story.
Yeah.
Julia Childs.
Yeah, she's the shit.
That's what I like learned
So,
about.
She's an American that was learning in France during
Yes.
And
Now, how do I switch my? This is frustrating.
How do you switch what?
My window again, because now I want to go to Remix, and I'm going to deploy this.
That's fine. Just do it.
Actually,
Ready?
I think I know how. I think I can go to the browser and paste this link.
Okay. Done. Let's see if it works.
and Maybe.
Oh yeah.
Okay. So.
Does it work?
Yes, this is going to be shitcoin dos or SCD. It's
Shitcoin dose. I mean, we don't actually have to deploy it. If you tell me what it is, like we don't have to like
yes,
go
but
for the.
well,
For,
but
all
I
right, yeah, you can do it totally. Like if you want to go, I'm here with you.
This is so we have currently have no. So you compile the token.
So can we look at the extremely complex syntax here?
Which part of it?
Just so
Nice.
we just take out some of the mystery here. So you're importing directly from the Open Zeppelin contracts.
Yes.
So what we'll find is
importing-
that ERC20 standard is just not a actual thing, but rather a class of Ethereum that has functions that everybody agrees upon.
Mhm.
So actually, do you want to?
Shitcoin DOS.
You just want to look at that real quick. Just can we can you copy and paste that URL, the contract URL that you're importing?
Yeah, if you want me to look at this for a little bit, I think like ERC20 is so simple that
You know
everyone
what?
should be familiar with it. But I
You know
understand
what?
people are not.
We're kind of just bulldozing over a lot of complexity, and I don't believe that.
Transfer amount.
Wait,
name.
can we zoom in just a little bit?
Yeah. So really, we should go to the interface. So
Yes.
ERC20, because this is a lot of stuff. But
Yeah.
is
You can do a
IRC20
Control F and just say contract or something.
So if we go to IRC20, this is the meat of what an ERC20 is.
Yeah, this is just the interface of it. That's good.
It has a total supply function, which gets total supply.
Mm-hmm.
Then you can get the balance of.
Now we have to explain here is that external means that what? External means that it will be
It can only be called by external things. So this
Yes.
can't be called internally by other functions. So I can't have a function in this contract that calls balance of. I have to be an external party.
Yeah, it even says it right there. At dev, moves amount tokens from caller's account to recipient. Returns
Yes.
a Boolean value indicating whether the operation succeeded.
And now
So
your allowance.
Yeah, so
Which
allowance
is-
is
How many tokens you've allowed the third party to transfer from you,
Mhm.
and approve, which is how you increase the allowance for that third party by approving them, and then transfer from, which is how that third party transfers tokens from you to that third party, which is actually really important because we'll see that shortly. And then two
Ooh.
events: a transfer event and a approval event. And-
emitted when value of tokens are moved from one account from to another account to. Note,
Yes.
value may be 0.
Yeah, that's one of the. I don't really get why that's even allowed to happen, but you can do it. You can transfer 0 tokens, which is just like throwing your money away. But
Right?
what?
What'd you say?
It's literally throwing your money away. You're paying Ether to transfer 0 tokens.
I've done that before. I've lost Ether exactly on that operation.
Taking a lighter and
On the
burning
wrong
your
wallet.
dollars.
On the wrong wallet. Like when you have the options in MetaMask, I thought I was on the right one. Nope.
Okay, so after that brief foray, now there's a few things that they're not in the basic interface that are in this more advanced token, which are the ability to add a name, a symbol into mint tokens, which is what this is doing. This is minting me as message.sender. I think that's 1 million. Yes, 1 million tokens with 18 decimal places of precision. So we've compiled it. You get the little green arrow of satisfaction.
Okay.
And then it's done. That's the beauty of Codan. Things just happen.
Can you show a multi-sig interface?
Let's see. So what's my new token? From where is my new token created? So I have to go to. Okay. Yeah, that is my new token. And so now I can, for example, add this to MetaMask. Add a token, custom token, FCD. There it is. So
Wow.
now I'm going to add liquidity.
You got to do
I'm
equal
going
amounts.
to select my token, and so it isn't very obvious. But if you simply let me see. So I guess I have to input. So if you paste an address here, and this isn't the most obvious, if you paste an address, Uniswap will detect it.
Your contract
It's-
address.
Yeah. So I can say add 10,000 of shitcoin dose, and then I need a base. So
I just love that emoji. It just doesn't know, so it's thinking about it. Just love it.
Yeah.
yeah, it's thinking about why would anyone want this token.
You know what?
But
That's a bad question.
Some fake.
Why wouldn't you want shitcoin dose? Is the better question.
And so I'm going to give it 0.2 ether value. So that means it's 0.0000 ETH for shitcoin dose.
Can we make Doge shit for the ERC20 instead of Dogecoin? Doge shit. It's like the wrapped version of Dogecoin.
We'll set the
Good.
price in the pool once you're happy. See, you're the first liquidity provider. So I'm going to. So first you have to approve, because what you're doing here is you're authorizing their Uniswap router to take your tokens. And so you have approved. It's going to take a second because I'm about to approve again. See, it's happened, but or do I have to click X? Interesting. To supply, this is because it's happened. I've approved, but this is unfortunately okay. Cool. A little bit glitchy there. That's definitely can be improved. Probably some. I think a better event watcher needs to be put in place, but create pool.
Wow.
Confirm. You get the nice little loading modal here.
Loading modal.
Yes. And
Modal.
This thing would be spinning for a long time on Ethereum, but we are on Coven.
You are the first liquidity provider. Congratulations. So wait. So now, what if yeah.
So let's.
Now, can we go to your wallet and see what you get back? Like, do you get like a Uniswap token? Can we, if we can check that?
Yep, you do. Down, go down.
Yeah, so check this out. So I have SC to ETH,
Your
but
pool tokens,
where's my
44.72.
SC2? Interesting.
Your pool tokens. Okay, so you have pool tokens here.
Yes.
Yes. Wait, can we go back to your
44.
wallet? They need to use async promises in JavaScript. Can you show a multi-sig interface? We got Praveen on Facebook.
A multi-sig interface.
Oh, okay. So you have your other shitcoin and your shitcoin dose as well.
Yes. So let's see, Uniswap. What's happening here?
Token safety. Anyone can create. Anyone can create ERC20 tokens. They need to use async promises in
They should do a
JavaScript.
smiley face. Anyone can.
Yeah, yeah. Not like anyone can. You should be like anyone can.
Yeah.
Yeah, that's actually
That's the whole point.
That's funny.
thing.
He's
It started to show you how easy it is.
Warning, anyone can. No, warning. Or great news.
Great news.
Anyone can.
So what's interesting here, though, is it's not detecting it. I wonder if that's a limitation in the front end.
What isn't it detecting? What are you talking about?
So I just created the second pool, and so it has the first pool, right? But the second pool is not being detected.
Do you have to point it to your Kovan?
No, hard refresh the page.
What's
Yeah,
the
do
hard
shift.
refresh?
Hard refresh is holding down shift while refreshing.
Okay.
Control Shift R. And it should clear out the cache, and then you'll have to check for it. So it won't just be as.
Why isn't my shitcoin listed?
No? It didn't come up yet?
Darn it.
It's there. Just put in the address.
It's certainly there. It happens. I have the pool, but
He's like, trust me. Wink.
Interesting. Now this is a mystery.
Did anybody create like a Rick and Morty currency yet? Like
Let's see.
ruble?
I'm gonna try and add some liquidity.
What do they call it?
Actually, because that's the one thing I haven't done here. So I'm gonna select the token. SC.
Neat.
Let's see.
This is neat.
Interesting. This is kind of glitching out here. Ooh, that's not giving away all my test ether.
No, not my test ether.
Yeah, I mean, this you have to actually do work to get it. It's not like really free if you value your time.
Ooh.
Think about it. I have to do the work of filling out a form, and if you can calculate time equals money, then test ether is not really free.
All right. We need to make.
But
they may create a Flairbo token for Rick and Morty yet, because if not, I'm doing that tonight.
Your liquidity. Wait, I'm confused here.
Flairbos. Coin market cap.
Let's see. Weird. Anyway, this is getting glitchy. It could be a whole live stream of me trying to figure out why this doesn't work. And I have an idea why. However, I don't think that's the best use of our time here. So I think a better use of our time is to understand when I create a pool, what actually happens on the back end. Because I think that's the juicy info everyone's wondering. or people want to know, rather than just like, oh, because anyone can go fill out the front end, and if you use their real site, it will probably work.
Right.
So what do you guys think? You want to see a bit more of the meat of the smart contracts?
100%.
Okay, so
Because I think that's what we do here is just like go for that, the delicious crab
Yeah.
meat of cryptocurrency and see, what projects are actually good.
so I guess I should start with the Uniswap factory contracts. Because it's kind of the important. That's the base, so to speak, of everything. So that is here. Can you see what my remix screen?
Yes, but yeah, if you just print that over, sweet.
Yeah. So this is my Uniswap. This is what's called Uniswap B2 Factory, and it's aptly named Factory because it just pumps out pools of tokens that can be swapped.
Praveen was saying maybe adding a second liquidity provider could fix the glitch, perhaps, but who knows? But
Yes,
that's neither here nor there. But yeah, it could be.
that would get a bit tricky because I have to manually find that pool address.
No, we don't have to.
We
as
could,
long
but-
as long as one of them showed up,
Yeah, but
cooking show style.
in our limited span of time.
Yeah, we want to get to
on
the
this
crab
slowly
meat.
spinning piece of rock.
Get to the
Yes.
crab meat.
We gotta get the crab meat before we get too old.
Yeah. So we gotta look at how these actually work. So this Uniswap factory, it's a factory that pumps out token pools. It does this by calling a create pair function. And this is let's see, token A, and so this does some basic checks to make sure the tokens are different. Obviously, because you don't want to swap your shitcoin for your shitcoin. Wouldn't make a lot of sense.
You just gotta make sure you got your shit coins in order.
Yeah, so they have to be valid addresses. And they do some nice math here that actually orders them. So they use a ternary operator, which is something I've never actually used in any of my smart contracts, but obviously exists. So they check.
So if it's something, it's basically without saying if.
Yes, they order them by value comparison, which is interesting because these are addresses. So they're ordering them essentially by comparing the numeric value of the addresses, which Solidity can do. Because a really interesting feature of Solidity is 0x numbers actually can be interpreted as fixed point numbers. It's just a weird thing, but you can compare which address is more than another.
Okay.
Yeah, I would love an explanation of really why that exists. But it's kind of an unstated important thing. Basically, and so then they check that a pair doesn't exist, and then they get the bytecode for a Uniswap pair contract.
Okay.
And then they create a bytes 32 from a hash of the token contracts.
Mm-hmm.
And then they use some assembly to create a new contract, which uses the mysterious create2 opcode.
Harrison chat, what's up?
Very interesting properties, but suffice to say, this is deploying a contract. Now, why? Now, why they chose to use this particular assembly code rather than simply
Nice.
using the new keyword? I'm not sure about that. Would require some research, but there's probably a good reason if you're doing it. And a great stream would be to go into the dark world of
Zoom in.
Solidity assembly.
Yeah, can you make this the text bigger by maybe one more zoom?
Yeah. So, but
Perfect.
suffice to say, this pair function is the address of the newly created pair contract.
Okay.
And so then they initialize the pair interface via the address, which
The I is the interface.
yeah, and so initialize it basically. Well, let's see. I have to get into the. We'll have to go into the pair contract, but that basically sets up the pool.
Yep.
Then you set some mapping of the token pairs to the pool. Then adds it to a list.
Which part of the pair? Which part of the pair contract are we using? Let's see.
This is the factory. So that's all the steps in creating a pool. So that's what. And so this contract, so when I click create add liquidity, and when it creates a new pool, it calls this and then creates the new pool. And so then we're going to briefly look at the, let's see, Uniswap pair contract, just so people understand what that is. Because this handles all the functions of the actual pool.
I can switch over to mine real quick, and I have the it up right now, so you can see. Can you see my screen?
I cannot see your screen. I got to switch back over to that.
Oh, don't do that. I'm just I'm just narrating what you're saying. So like, okay. If we're talking about the pair, I have the documentation up.
Yeah, so that's actually a pretty good way to look at it.
Yeah, it's a little bit more readable, but what these are. And you can see here on the side is that we have events, the approval event, the transfer event. But read-only functions are the name, the symbol, total supply, decimals, balance of, blah, blah. But also nonces and state-changing functions like approve, transfer, transfer from, and permit. You can see that this is the ABI here. But I'm going to switch back over to you. Ready?
Okay. Yeah, can you see my screen?
Yes.
Okay, cool. So this is the Uniswap pair. This contains all the pair functions.
Yep.
And it's a whole lot, so I'm not even going to try and cover it all. But the important things to know, this is the initialize function.
Yeah, that's what we just called.
And all that does is set the token addresses. And now so that should be known, and there's a burn function that removes the tokens.
Because you get back that swap token.
And there's the essential swap contract.
Because that's what you ultimately you get is that token, and therefore it needs to be burned when you're done with it.
Yes, so but
because you're now taking out your stake in the pool.
Important thing to understand though is the mint function that mints your liquidity tokens.
The level function should be called from a contract which performs important safety checks. So it accepts a address, the to address, and returns a integer liquidity.
Right, and your liquidity is a token value.
So, continue.
Right, so this liquidity is used to you actually earn fee values for adding liquidity. That's why you get these tokens, and you can exchange.
And that's like 3%, right? Or 0.3%.
Look up the docs.
I think I remember it's 0.3% or something.
Mm-hmm.
Which is decent.
This mint function. So let's see. There's there's basically, let's see, the reserve.
Yeah, get reserves is like it's returning a tuple. It looks like.
I think it keeps a certain amount of both for paying fees.
Mm-hmm.
So yeah, so it takes out a mint fee.
Okay.
Let's see, gas savings, total amount mint fee, square root. Ooh, square root function, solidity.
Yeah, so it looks like if you're using the square root, they're solving for liquidity, which was squared, right? Sub minimum liquidity.
So basically, it would be amount 0 multiplied. So it's the square root of amount 0 times amount 1. That's sub minus the fee.
Yeah.
And that's if total supply is equal to 0.
So then the actual liquidity that we're going to be returning is now at the floor on line 123. So that's it's the quotient. It's the floor amount of when you multiply. No.
Amount times total supply minus divided by the reserve.
Yes.
Yeah.
Indubitably.
So the point is they basically calculate a liquidity value and you get that. They mint. But the important thing to notice here though is there's no checks. So if you create a new pool and then anyone can call this and get the liquidity, there are no safety checks here, as it mentions up here. So if you were to just use this Uniswap factory to create a pool, then the first person who was able to see the transaction, or who even got lucky because there's no necessary ordering to Ethereum transactions. So someone would see that event and they're like, ooh, and then find the address and I'm getting those liquidity tokens.
I like it. You're just like, ooh.
Yeah, it'd be exciting. It's basically free money for.
Yeah, so you're like, ooh. Yeah, it's like free money with your money.
And so that's why there is this Uniswap router.
Yes.
What the front end is doing.
Let's see. I can probably get to the router 01. I'm going to switch back to my screen.
I guess it's 02 because this is version
2. Oh, you want
2.
02? Okay, let's look at it.
Yeah.
02. Because routers are stateless, they do not hold token balances. They can be replaced safely, trustlessly if necessary. This may happen if more efficient smart contract patterns are discovered or additional functionality is desired. For this reason, routers have release numbers starting at 01. This is currently recommended release 2. So that's Uniswap v2 router.sol, which is found inside the GitHub repository. Let's see. Their address is 0x7 blah blah on mainnet, Robson, Wrinkleby, Gorley, and Kovan. It was built from commit blah blah. So it has a factory, a weth function, which we spoke about earlier. Add liquidity function. Oh wow, yeah, there's a lot of stuff here that goes on.
Oh yeah, but if we look at the add liquidity function, what this does is
I'm looking at it right now.
Does all the steps essentially.
So we're looking at it. It says adding liquidity to ERC20 pool covers all possible scenarios. Message.sender should have already given router an allowance of at least amount A desired divided by amount B desired on token A and token divided by token B. Always add assets at the ideal ratio according to the price when the transaction is executed. If a pool for past tokens does not exist, one is created automatically and exactly amount A desired, amount B desired tokens are added. So we have token A, token B. Let's see what other things we're looking at. To address deadline, Unix timestamp, which after the transaction will revert. And we have liquidity, which is actually going to be returned for the amount of liquidity tokens minted.
Yeah. And so this bundles the whole steps of initializing the pool
Mhm.
and minting liquidity tokens into all one transaction so that someone can't do that attack of just taking your liquidity.
Which has already happened. I think it was like 300,000 was lost inside of a liquidity pool.
What was
Recently.
that?
It happened recently. I could go find the article, but I don't want to.
Okay.
But I know that it was
There's
like
a
kind
lot-
of traumatic.
There's a lot of complex calculations here for the exact amounts.
Do you want me to go back? I'm going to go back to your screen. Ready?
Yeah. So
Ready?
okay, I thought we were on.
No, I
Cool.
was looking at my screen. That is your screen, but it's
Okay.
the documentation.
Yeah.
Ready?
So
New.
when you add liquidity, you call this function
Yes.
with your token A and B, the amount of A desired, the amount of B desired, the minimum amount, the address, who gets the liquidity, and a deadline.
Harris says can't recall encountering that lock keyword.
Lock keyword.
Yeah. I guess we'll have to go back. But continue.
Yeah. So this handles let's see. Quote amount desired. So this both calculates the amount of tokens you can add, yeah, which is based on probably the most expensive token based on the relative value, because it has to be equal. Or if you create a new pool, it will set them equal no matter how many you put in. But once the pool is created, there has to be a certain amount. So they do a fairly complex amount of calculate. They do a whole complex set of ifs statements. But the important takeaways are, if a pair does not exist, you create a pair, and then it will guarantee, it will mint these tokens to whoever you select.
Mm-hmm.
So basically, the creation and the minting is all handled in one step with a calculation of an optimal amount based on their own price oracle, which is pretty cool.
Yeah. So what they do is essentially is that the core contracts are not upgradable, which adds security in the minds, or at least in the person who's using Uniswap, and then these routing contracts are the ones that can be, because that's the ones that use them. Correct.
Yes, but
Right.
oh man, this is one
Safe
of the
transfer match. Ooh.
largest smart contracts you can find.
Juicy.
Yeah. Let's see if we can deploy it. So Uniswap factory. No, just Uniswap. Nah, that's what we want. The interesting thing, if you do it without optimization, it will error out. Or not error out, but it will give you a warning that this may not even deploy.
Like, what are you doing?
Yeah, it's 24,576 bytes.
A limit was introduced in Spurious Dragon. The contract may be deployed on.
Yeah, that's one of the
may
weirder
not be
compiler
deployed.
names. Like, if you look at all the other compiler, like names of cities, for the most part,
Yeah.
but then we get Spurious Dragon, Tangerine Whistle.
Yeah, it's like when you get a new username on like Xbox. Post Malone. Like,
But if we enable optimization,
let's see. This is not cooking show style, Julia.
Cooking show style.
Yeah. We are. I think we're good on that right now. Actually, we don't need to necessarily deploy that contract. I'm going to switch over and then we'll close out the stream today.
Okay.
Sounds good.
Let me just come back. So, just to go over what we did, we had we forked both of the core and front end repositories, so we could change the environment variables, so we can compile it and use it on our own machine. We deployed via Remix our own shitcoin twice. We created a pool on Uniswap via the front end, and then we did a deep dive into the inner workings of the contracts and their JavaScript implementations. There's really good resources online for this, and I'll
we
post some.
barely skimmed the surface of Uniswap because, like,
Well, we skimmed the surface, but it was a deep dive more than any I've seen on any other show.
yeah, I mean,
Someone will just be like, use Uniswap. Like, how does it work? Like, not only did we go under the hood, we went on top of the hood.
yeah, if anyone wants to go super deep, there's an actual academic analysis of Uniswap markets on Stanford.
Can you post the PDF?
Where is that in the comments? Where can that be
Post
posted?
it in a comment. Just post it inside of the stream documentation.
Okay, so I will post that in the stream chat or our stream chat, and that
No, the doc that I make every time. It shares with you at the same address on Google.
Well, it's
You
in our
post
private
it,
chat, but
sure. But that
yeah,
will
it's
get
actually
destroyed.
But yeah, they use calculus to show that you can prove with calculus that it actually replicates the fair market value of these tokens.
Okay.
And there's whole apps people developing whole apps to basically optimizing your gas fees and minimizing what's known as price slippage. Adam, are you familiar with that?
No, I didn't read the paper, but I mean, it all makes sense.
The concept of price slippage.
Yeah. I mean, so the more I dump, the more change I have in the marketplace, given a lateral movement. So like if I have a curve that's up and down and I drop a lot of token on the market, it's going to move a different point, and it's going to cause, as I'm selling into the curve, an adjustment in the price because I'm acting on the actual demand of the market, like eating away from it. So like I continuously, the more I dump, the more slippage I experience as a seller. So this is like a key concept with Zap. Like price slippage is like a big thing for us too, because there's drawbacks and benefits to having an automated market maker, right?
Yep.
So
so slippage from Investopedia.com says slippage, it refers to the difference between the expected price of a trade and the price of which the trade is executed. Slippage can occur at any time, but is most prevalent during periods of high volatility when the market orders are used.
I mean, yeah. So like you're always doing a market order with AMMs. It's always a market order, right? It's not like you're, unless you're using a bot to like execute. Basically, the supply and the demand are always readily available, and the price slippage is what adjusts the price. I mean, it is a little bit complicated. Maybe we should talk about like market economics and like automated market makers as like a separate thing.
How about? Well, I think that's a bit out of the scope, and I will post the PDF talking about the analysis of the Uniswap contracts. But you know what? Thanks for everyone coming to the stream. We did go deeper than most. We could go deeper and deeper. Maybe we could go on to that analysis.
Like we could do 3, not only Uniswap, but like its competitors and automated market.
Yeah, depending on how much love this gets, this post gets. Comment on this video if you want us to do another video on it. Honestly, if you really like the content that you're seeing, like, subscribe, and ring those bells, because with your input, we will basically drive the entirety of the stream. But thanks. this is Adam, John. I'm Eric from here at the Blockchain Center. We're super excited to bring you this content, and we were signing off. Thanks, John. Thanks, Adam.